The thyroid gland is situated at the front of the throat. It is made up of two lobes which are connected to one another in the middle. The narrow section in the middle of the thyroid gland is located on top of the windpipe, with one lobe situated on each side of the windpipe. The thyroid gland also has 4 parathyroid glands. There are 2 on each lobe. The thyroid gland is formed relatively early during pregnancy. Approximately 3 weeks after fertilization, the first thyroid cells are formed in the oral cavity from the same tissue that later gives rise to the tongue. The developing thyroid gland then travels down a tube, the thyroglossal duct, to its final location at the front of the throat. During this journey, the number of cells that make up the thyroid gland grows. The underside of the thyroid gland also begins to split, and the gland starts to take the shape of a butterfly. Once the thyroid is in its final location, it continues to develop. When the fetus is 11 weeks old, the thyroid gland is already working. If this development does not occur properly during the pregnancy, you may develop a congenital thyroid abnormality. The thyroid gland consists of follicular cells and C cells. The follicular cells of the thyroid gland together form the wall of a follicle, which is filled with a protein-rich liquid. The follicular cells produce hormones, mainly thyroxine T4, and a small amount of triiodothyronine, T3. These hormones are bound to the thyroglobulin, Tg protein, which is stored in the thyroid follicles. If they are needed, T4 and T3 are secreted into the bloodstream and distributed throughout the body. Thyroid hormone influences the metabolism of virtually all bodily tissues, and it stimulates longitudinal growth of the bones and the development of the brain. The production of thyroid hormone is complicated. A great number of steps have occurred before you end up with active thyroid hormone T3. Most of the T3 is made from inactive thyroid hormone T4. The thyroid gland itself produces primarily T4. T4 and T3 are synthesized in the interior of the thyroid follicles. The amino acid tyrosine and iodine are needed for this. Iodine is ingested mainly via salt, which is in bread, for example. Once the iodine has been taken up in the bloodstream, it is transported into the interior of the thyroid follicles via the thyroid follicular cells. The follicular cells also make thyroglobulin Tg and transport it into the interior of the thyroid follicles. Thyroglobulin contains tyrosines. With the help of the enzyme TPO, iodine is converted into another form and is bound to tyrosine. Tyrosine can bind to 2 iodine particles. We call tyrosine with 2 iodine particles DIT. T4 has 4 iodine particles and is made when 2 DITs bind. Tyrosine can also bind with just 1 iodine particle. The result is an MIT. T3 has 3 iodine particles and is made when 1 DIT binds to 1 MIT. T4 and T3 bound to thyroglobulin are stored inside the thyroid follicles. When your body needs thyroid hormone, bound T4 and T3 are taken up by the thyroid gland cells. In the cells, the hormones are unbound from the thyroglobulin, brought into the bloodstream, and are distributed throughout the body by the blood. The secretion of the thyroid hormones, T4 and T3, which are stored in the thyroid follicles, is very precisely regulated by your brain. The hypothalamus in the brain produces the hormone TRH. TRH signals the pituitary gland to make TSH. TSH travels to the thyroid gland via the blood and stimulates the thyroid gland to release T4 and T3, as well as to synthesize more T4 and T3. The thyroid hormone is then distributed via your bloodstream to all of the tissues in your body. When there is enough T4 and T3 present in your blood, your brain receives a signal to produce less TRH and TSH. As a result, the thyroid gland synthesizes and secretes less thyroid hormone. This way, the amount of T4 and T3 in your body is kept in balance. The thyroid gland primarily produces T4. T4 itself is not active. To become active, it must be transformed into T3, the active form of the hormone. This conversion takes place in all of the tissues in your body. During the conversion of T4 into T3, the enzyme deiodinase splits off one iodine atom from T4, creating T3. Thyroid hormone affects virtually all of the tissues in your body. The active form of thyroid hormone T3 increases the metabolism and with it your energy consumption. It increases your heart rate, blood pressure and rate of respiration. It stimulates your longitudinal growth and the growth of your brain during gestation and in the first 3 years of life. And after that, thyroid hormone continues to stimulate the functioning of the brain. If your thyroid gland works too slowly, then too little thyroid hormone T4 and T3 will end up in your bloodstream. We call this hypothyroidism. If your thyroid gland works too quickly, then too much thyroid hormone T4 and T3 will end up in your bloodstream. We call this hyperthyroidism. Something can also go amiss with the growth of your thyroid gland. If the entire thyroid gland grows too much, we call that goiter. If only a portion of the gland grows too much, a nodule is formed. A thyroid gland abnormality that is present at birth is called a congenital thyroid disorder. If the abnormality arises later, then we refer to this as an acquired thyroid disorder.